So I titled this talk All a Question of Timing, particularly looking at how timing could be useful in neuroscience and neural engineering, and particularly looking at ways to be able to look at abnormal movement, as we've just heard. But I mentioned this particular figure at the very beginning on Monday, talking about all a question of money also, the 800 billion that we're spending in Europe looking after people with different brain disorders. So this is the cost annually per year that is taken for looking after people with different forms of brain disorders. So it's a huge amount of money. In terms of the number of people who are suffering from these conditions, I mentioned this also on Monday, 170 million people with different forms of brain disorders. So it's a huge number of people and a huge amount of money that we spend looking after people with that condition. So this is really important to kind of look also about where is that money going and which patients require more care, and maybe we should be directing attention looking after some of those. So we can see here, this is the cost per patient in Europe for different conditions associated with brain disorders, from headaches, for example, at the very top up there, as you see, all the way down through to stroke. And at the very end, we have neuromuscular disorders and multiple sclerosis. So they're costing in and around 30,000 euros per patient per year to be able to look after those individuals. And we've approximately 10 million people in Europe with different forms of movement disorders. So this is where, I suppose, neural engineering and what we're here about this week in between the various conferences that make up this conference, being able to look in different ways that engineers and clinicians and neuroscientists can come together to try to understand systems associated with, I suppose, the nervous system in general, and how can we interpret and understand that process a little bit better to be able to offer some hope for these individuals. So neural engineering, I think, is important now, because I think we know a little bit more about how the brain processes information. Still a huge amount to learn in that particular area. We have new signal processing tools that are continually developing, being able to look at nonlinear, non-stationary systems, as we heard earlier, and as we'll hear later on this afternoon. How can we apply some of the signal processing to big data and how that could be important? We have different materials that can exist inside the body. We've heard lots of talks about those this week in terms of their biocompatibility for chronic recordings of implants, for example, and stimulation. And also then, I suppose, all of this ties together because we've got great clinical need to understand what's going on. So the area that we've been looking at a little bit has been human movement, and particularly trying to understand how human movement comes about. Obviously, it's necessary in many ways to be able to look at coordinated movement in terms of the musculoskeletal system, but also there are neural processes involved as well. And in fact, any breakdown in any of these processes is going to result in some form of abnormal movement. So the focus I'm going to look at is a couple of different themes, and the first is going to be looking at dystonia, particularly adult onset primary